If fire needs oxygen, where does the sun get oxygen if there is no oxygen in space? That was a great question that confused scientists even into the 20th century. Where was the oxygen? Then again, they calculated the mass of the sun and its energy output, which led them to the conclusion that the sun ran out of energy a long time ago. Even if it started now, in a few hours the fire would be out. What was going on? The answer is nuclear energy. The sun doesn't burn, the sun fuses. It takes some hydrogen atoms and turns them into helium atoms, spitting out the extra energy. Indeed, this was a scientific problem for hundreds of years. If the sun consisted of oxygen, it would run out of fuel in a few hundred years, so what's the deal? But wait, nowadays we know more. What about the other objects that glow like the sun, even without oxygen? This example of a light bulb shows that not all objects that shed light need oxygen to do so. Of course, for light bulbs, that gas is typically some inert gas like what can be found in any light bulb in the modern days. In fact, the light bulb doesn't use up the gas. Instead, it uses an electrical wire heated up by electricity flowing through it. The wire heats up in turn, heating up the gas. The sun is a bit similar to a light bulb. From early spectroscopic studies in the 1800s, we know that it consists of gas, mostly hydrogen and helium. Nowadays, we also know that this gas is heated up not directly burning its chemical constituents, but by a special phenomena that is reverse of what's happening in nuclear power plants. While in nuclear power plants, uranium splits up and by doing so releases energy, in nuclear fusion, the hydrogen atoms combine to form helium or even more massive particles. In case of light particles like hydrogen, this again releases large amounts of energy. The energy release speeds up the particles in the sun's core, and in turn, these superheated particles slowly bounce around and race to the sun's surface. There, the temperature of the hydrogen-helium gas is 5,500 degrees Celsius or near 10,000 degrees Fahrenheit. A gas this hot will glow literally like the sun. Sun continually loses a tiny portion of its mass to keep shining, combining hydrogen to helium in its fusion forge, its core. From observing other stars like it, we know it has enough nuclear fuel to shine for another few billion of years.